Once you've loaded your data, it's time for cleaning. This is where R++ comes in with a range of tools to help you quickly understand and refine your data. For example, with a single click, I get the graphs. Then, with a second click, I get the summaries. Any outliers are immediately obvious. If I click on height, the graph zooms in and I see one child who's apparently 12 metres tall. To fix this, I simply click on the column header to sort and edit the value to correct it. Next, there's the septic shock variable. This is binary, so it should only have 2 categories, but we can see on the graph that there are 4. To correct this, we use the type editor, which lists all the values. We merge the incorrect ones by dragging and dropping them together, and that's all it takes, it's corrected. We've added colour coding in R++ to indicate variable types. Blue is nominal, orange is binary, purple is dates, and green is numeric. Here, I see the age and days variable is blue. This usually means there's a typo where someone has entered text instead of a number. To find it, I just need to convert the format. R++ brings the problematic cells to the top of the column. I correct it, confirm, and it's fixed. Once the data is clean, you often need to enrich it by adding new columns. To make this easier, we created a column adder. It gives options based on the type of column selected. For numeric data, you can split into 2, 3, or even 4 parts, basically dividing it into slices. For date variables, it enables date calculations like the difference between dates with results shown in days, weeks, or months. After cleaning your data, it's time to explore bivariate analysis. With R++, it couldn't be easier. First, select the variable of interest, say septic shock, which moves to the left to become the variable. When I click on graphs, I get all the visualizations of every variable against septic shock. It automatically chooses the correct plot, a mosaic, or bivariate bar plot for binary comparisons, or box plots for binary versus numeric data. When it comes to statistical tests, it's often a challenge to know which to use when. Luckily, with R++, you simply click here and it works it out for you. It runs every test between every variable and septic shock. It automatically selects the right test each time. Chi-squared and Fisher's exact tests for binary-binary comparisons, and students' t-tests and Wilcoxon ranks for binary numeric comparisons. If I find a result interesting, I can export the graph to Word with a simple drag and drop. I can copy and paste the results table, and best of all, I even get a ready-made draft of an article. I just copy, paste, and the results paragraph is written. R++ offers 4 main models: linear regression, logistic regression, ROC curves, and survival analysis. Each one follows the same principle. On the left, you have your list of variables, where on the right, Rinell, our mascot, guides you on which variables to select and in which order. For example, with linear regression, I choose the variable to be explained, then the explanatory variables, and the model builds up step by step. For logistic regression, it's similar. I select the dependent variable, which must be binary, then select the explanatory variables, and the logistic model appears. To add these results to an article, I copy and paste into Word, and if I want a ready-made paragraph, I simply paste the draft provided. ROC curves are just as easy. First, click on the status variable, then select your predictor variable, and you'll have your ROC curve. You can add up to 4 curves on the same plot to compare areas under the curve, and even display DeLong tests for pairwise comparisons. Finally, for survival analysis, I pick the duration and sensor variables to get the Kaplan-Meier curve. Adding a grouping variable gives a log-rank test, and further adjustment variables build a Cox model. Beauty is in the eye of the beholder, and beauty is even more in the eye of journal reviewers. This is why R++ includes a graphics editor. You can adjust almost everything: the graph type, switch to black and white, change DPI, fonts, sizes, and even add a p-value. Or you can use styles from major journals. If I want to publish with Elsevier in black and white, I select the style for all graphs, and it's done. To export, just drag and drop. Many journals require the first table of an article to compare the treatment group with the control group. This isn't difficult to build, but it is time consuming. Calculating every mean, standard deviation, median, and count one by one. R++ makes this easy with a Table 1 editor. First, select your grouping variable, as kindly directed by our mascot Renal. Then, click all the variables you want in your Table 1. The table builds as you go. Once you've chosen all your variables, you can fine-tune it, remove medians, or not, add a column for p-values, and more. When it's complete, just copy and paste into your article, and your Table 1 is ready. So there you go. That was R++ in just 5 minutes. I haven't shown you everything. There's still plenty for you to discover on your own, like PCA or propensity scores, but we've got the essentials. With R++, stats are super fast.